Hello and welcome to the last session. The title is Evolving with Java, How to Remain Effective. I believe you had a lot of good sessions in the conference and learned a lot. In this talk, I'm going to summarize what I learned by evolving with the new versions of Java over last 15 plus years. My name is Naresha, and I help teams to get better with their technical practices so that they can improve their productivity and deliver better business value. This year is something special for especially for the Java developers, as Java has been here for over 25 years, and that's a long time for technology. And many of you might have been working with Java for several years, and some of you might be relatively new also. So in this presentation, let me share my experience or my journey with Java. Java has also evolved, and I got an opportunity to, several opportunities to work on Java in the last like 15 plus years. A good practice is always to start with the why. So let's do that. So talk about the business value. Of course, as developers, it's very important for us to deliver true value to the business. Otherwise, there's no way for us to survive, right? Of course, you understand what is important for your business and deliver that to the users and the customers. In today's presentation, let's understand how we cope with the change from the technology side, change from the business side, something you know already how you cope with. You know your business very well. So let's focus on the technology aspects today. First thing is like, of course, you are able to deliver your application, say, without defects, but can we deliver features faster, right? Can we reduce the time to market, or can we, increase the speed of delivery? That's an important question we have, and all of us are trying to improve on that. Of course, we know time is money, but on the other side, we also try to optimize so we can save cost, how we can develop quality software in reduced cost. That's also an important focus we are trying to do. So let me show you exactly one example from the modern Java, so that I can illustrate how features of modern Java cater to these qualities. Right? You take there are two pieces of code here, what you see, and which are mostly doing the same thing, but the main difference is that the first piece of code is executing sequentially, whereas the second piece of code makes use of parallel streams, and hence the computation can run in parallel. Notice the difference, right? It's a very, very small. So what you can understand from here is that the structure of sequential code is very much same as the structure of parallel code, right? So for some reason you believe parallel stream, making use of parallel stream is better, and you switch to that. And since the entire stream usage in your application will make use of single thread pool, what might happen is that some other part of your application might be starving if this part of the code is busy executing. So while parallel execution is really, really good from the throughput perspective, is it really good from the perspective of getting responsiveness to all users? That's a question. So in that case, say, even if you want to switch back to sequential execution, you can do it really faster. So that of course you're very quick in switching between these two modes, and also you can be the since the structure is very much same, you're not going to put a lot of effort in moving to parallel stream or converting a parallel stream of code. Just if you're familiar with the thread based code, you can imagine how that code would look like. So I believe from that you understand that modern features from Java can really help you to be more productive. With that, let's start our journey. Let me start by sharing a story from early days of my professional career. So what used to happen is this statement might be very, very familiar to you, right? Often we want to log something. So this is how you would create an instance of logger. In this case, I'm using SLF for J. Though in the initial days, it was more of log4j or any other variants of that. So what we used to do is, like, typically what I had done was like, when I created a new class, I had copied this statement from the previous class. As a result of that, my new class is logging with the name of the old class. So I'm not able to not able to retrieve the log what I was looking for from the log files, because it was copy pasted. Not because of that, it did not have the original, I mean the new class name. I spent more than 4 hours or so, and I couldn't figure out anything, and I called it end of the day. And the next day, I could quickly figure out that this was the mistake I had done. Then, interestingly, what I did is I used the IDE template. You could create a template in your IDE, and with that you could supply key and auto generate the code for the logger, something like this. This is just for a demonstration purpose, even though originally those days I was using Eclipse as the primary IDE. So I just thought about this, right? I was very much familiar with this feature of the IDE. However, I had not put any effort to set up the template in the IDE. It is after that, spending 4+ hours, that I decided to make use of this, right? So it was that pain that caused me to take some genuine action. With that, let me introduce a model that we can, all of us can make use of for evolving in our evolving our code base, or adding making things better, improving our life, right? At least to trigger action. But let me start with a disclaimer. All models are wrong, but some are useful. So if you really want to prove that the model is wrong, you may be able to find some example for that. But the idea is that we find some motivation to trigger some action. So pain. What do you think about pain? Is it good or is it bad? I'm sure people might be thinking, okay, pain, why would it be good? It's bad, right? So let's make it good. How do you make it good? We put pain along with the suffering. Now say you choose pain or suffering, what are you going to choose? Of course, pain may be better, right? So if you just touch a hot plate or fire, immediately you'll pull your hand back because of the pain, right? You, if you don't do that, or if you don't sense that, eventually you may be hurting your organs, which is not good. So in that way, it may pain for a while, but still pain triggered some action. In that case, of course, it was a reaction, not necessarily a planned response. But that way, pain can help us to trigger some positive action. That's the key thing. So if you look at the example I mentioned before, it was the pain that triggered some action from me, even though I knew how to solve that problem beforehand. Immediately, you may have a question. That's okay. I have not experienced the pain yet. What should I do? Of course, you can rely upon your friends who have, been working in the technology or in the same application for a long time. They would tell you how they would share their experience. Okay, this is what I was trying to do, and these are the areas where I really have to struggle to get these things done. So you can rely upon somebody who you know to get the pain of the previous way of doing things. So that's how whenever you learn a new technology, either if you have experienced the pain, you would readily embrace something that is newly available, or if it is not, before you implement, before you adopt those features, make sure that you ask a question. Okay, what would have been the pain that triggered this feature, right? Triggered the development of this feature. You can ask the same question, for example, like maybe JPMS, Java Platform, module system. Okay, now certain things library developers wanted to keep private, but then people used all those APIs. Now they cannot change that. That's one of the motivations or one of the pain points people had, which is addressed by JPMS, right? Similarly, you could ask like the newer features like records, for example. What triggered that? There was a lot of effort in you had to write a lot of verbose code, right? Overriding equals, hash code, and so on. So now these records make creating data classes much simpler, right? That's how you could use this pain principle uh, to drive action and evolve. With this, let's take a few more examples from the evolution of Java and see what else we can learn from, right? Beyond moving from one version to other, what in general we can learn from these, moving to newer versions. Interestingly, string concatenation is an area where you can learn a lot. And let's take this simple example where I'm using a typical plus concatenation operator for concatenating, but then, uh, you might have, if you are working in those days, you might realize, okay, there were articles explaining, okay, this might not be a great idea because string is immutable. And every time when you do this new string instance gets created, and maybe using a string buffer is a better idea because conversion to string happens only at the end here, right? That was one of the reasons. Now let's see, we followed those instructions, and you the so-called best practice you embraced, and you use string buffer instead of plus. Let's see what happens, right? So this is what happens in string. This is a JDK 1.4, right? Wherein you use a string buffer. This is for the first one, actually. Using the concatenation operator plus, which also under the hood will use string buffer. Only the additional is that every time it will get converted into string, creating an extra string object. But now the same concatenation code, when you compile with the Java 1.5, see, it uses instead of string builders, another class called, instead of string buffer, it uses string builder. String builder is functionally same as a string buffer, but string buffer was thread safe and string builder isn't thread safe. But since we are using it in a as a local variable, we don't care, we don't have a shared mutability problem here. There's nothing shared, so mutability is not a concern for us. So string builder doesn't do anything, right? But so we get some performance benefit with the string builder. Now you would say that, okay, people who were aware of the best practice, they did something, and people who are not aware of the best practice, they didn't use string buffer. Instead, use the concatenation operator plus, and now the one who gets benefit is the one who did not embrace the best practice. Oh, this is very bad, right? You really want to cry, because it's like punishing the punctuals, right? Who people who come on time and say, okay, let's wait for everybody else. uh, that's the kind of feeling you would have had those days. So let's ask this question, like what code is more maintainable, and what we can learn by going into this and exploring this a little bit. So let's compare plus versus string buffer. I mean, it started with string buffer. Right? So level of abstraction, concatenation, you would see is slightly at a higher level of abstraction, because plus concatenation operator gets converted into string buffer or string builder, depending on where you use. So concatenation, of course, is the API. They are pretty much compatible. However, string buffer also has an additional responsibility of thread safety, which we don't need in at most of the time when nothing is shared, right? Local variables are not shared. So it has additional responsibility. However, the concatenation has a higher level of abstraction. So what we can learn is, by favoring higher level of abstraction, you might end up with the less maintainability, less cost of maintenance. Whereas if you get into lower details, there's a potential that you may have to, end up incurring more cost or effort for maintainability. This is in general. We have to take it as a general rule. Of course, there could be exceptions to this. And also, a related principle is premature optimization is the root of all evil, comes from Donald Knuth. And the reason why he was talking about is that people often, try to optimize small parts of the program which might not be widely used, right? For example, say if you have a method that gets invoked, say over the month, and that too when some admin user logins and does something, if you improve, say the method takes 1 second and you reduce it to half a second, it might not make much difference. Whereas you have a certain method which takes, say, 500 milliseconds, but gets invoked by several thousands of users every second. Even if you improve it by, say, 100 milliseconds, I think you're going to get a huge benefit, especially if you're operating in a large scale. So I think you understand that, and we can make a trade-off by comparing what is the effort and what is the return on investment we are going to get. But in general, higher level of abstraction may be a better approach, or at least that's where we should start with. And here is the rule for optimization. The first rule says don't optimize. The second says don't optimize yet. And rule 3 says profile before optimizing. So you profile your application and understand where is the real bottleneck, so that you get a real benefit of optimizing. And you have the link below for that. A related part when you are going to spend effort is like Yagni, you ain't gonna need it, which which is closely related to simplicity, because simplicity is when there is nothing else to remove, right? Nothing else to add. So you ain't gonna need it. Probably you don't put whatever is not necessary, so that you don't make things complex unnecessarily, or you don't end up increasing the complexity unnecessarily. You realize that, okay, there is a genuine need for certain thing here, whether it could be optimization or it could be dependency, anything like that, and only in that case you go and add it. So what I really like is like make it work, make it a better approach, which is which is typically known as iterative approach, right? And a related rule is like make it work, make it right, and make it fast. Make it fast comes at last, which you keep on iterating. Last bit from the concatenation. So we have seen like what happens with the Java 5, but in Java 11, if you compile the same concatenation code, you would see that it invokes invoke dynamic, which was added later, right? And it calls this make concat with constant. This code, which is invoke dynamic instruction, was added typically for dynamic languages to run on JVM. However, interestingly, Java 8 was the first language to take a real advantage of the new invoke dynamic VM instruction. So in the previous rule, we saw how iterative development is much better, or is the right approach. I'm a great fan of test-driven development, which helps in keeping the Yagni principle, or striving for simplicity. Though I'm not going to talk in detail about test-driven development, I do want to focus on one aspect, that is refactor. Right, refactor is a behavior-preserving transformation, so which you always do on a green state. Right, you make sure that all the tests pass. Then you change the structure of the code, which is essentially changing the design of your application without impacting its behavior, right? So after you refactor, now the structure is changed, design is changed, and you still ensure that it is in green before you want to add more features, which essentially means you have to write a failing test before that. So when you evolve or you embrace new features of Java, typically when it's a good time, or typically when is a good time to refactor. One is once you implement something, oh, it's working, ask, is this design adequate, can I improve that? You refactor that. That's one way, right? Another is, okay, you have done that, you are going to start with the new feature, and now ask that question, is the current design good enough to accommodate the new feature, right? If it is not, you ask the question, okay, I'm in a new version of Java now, is the design going to become any better by adding this new feature, or refactoring to use the new feature in the current features, right, in the current set of application feature I'm talking about. So in that case, you can go ahead and change your application, make use of new features of Java, then add the new business features. That would be a much better approach, rather than saying that, okay, now there is a new version of Java, let me go and add all the features one by one. That may not be a good idea. So in this case, over a period of time, you will really reap benefits by using new features of the language, or new features of any tools, by using the right refactoring technique. Another important aspect in this, like you have a method here, like get orders of customer. You would often see methods like this, which returns a list. But the question comes is, typically, like you will have an interface, and then there are one or more classes implementing this interface. So just by looking at the interface, I don't understand what of course I can say that it returns list, but what does the list contain? What is the type of the object this list contains? It's hard to determine from looking at here. I'll have to go to the implementation to understand that, which was one of the main problems I was facing when I was working with Java 1.4. And you would say that, okay, why not we put in the comments? But to be very frank, uh, most of my enterprise application development, I have not found any useful comment most of the time. You should be thankful if the comments are not outdated and misleading. Most of the times people change the code, but don't change the comments. That's very common situation. However, you can't even trust the comments blindly, so reading comment was mostly useless. And of course, you will have some redundant comment saying again the name of the method being duplicated there, etc. So in this case, generics really, like from Java 5 helps. Okay, now I know it's a list of order. I know how to use this without having to read all the implementation, the code implementing how to retrieve these methods, right? Retrieve these data. That's kind of helpful. Or sometimes if it is returning order or order summary, I can know very clearly from the method signature, which is of course compiler has to validate that, which is the benefit you get. So it's a kind of self-documenting code. Next, let's take a look at this again. It's from 1.4. At this point in time, you're using an iterator, which has few risks of like it has too many moving parts. And once you use the iterator, there is a risk of reusing this iterator. So by moving to 1.5, you end up writing the code which is less verbose, and again which is at one level higher level of abstraction. However, if you look at the bytecode, you understand that it is still using the new for each loop, which is still using iterator under the hood. So it's more or less, it's a syntactic sugar. Now you understand that there is a level of abstraction at JVM, and there is a level of abstraction at Java, the language level. Now, something can be added at the language level without needing extra support or reusing the same thing what JVM was using before. That can also help developers. This is a principle used by several languages other than Java that target JVM. So what we need to understand from here is that minimizing moving parts can significantly help reduce defects and improve the readability also. Another code which is imperative, and let's say we are using the streams API here. Again, when we see this, there could be initial inertia to move from the imperative code to the code at like Java 8 streams code, because it requires a little bit of understanding of how it works, or at least some basics of functional programming would definitely help here. However, if you notice that the code below, the older one, is the different concerns are all interweaved, whereas those concerns are separate, which makes the code more readable in the newer version. Also, the newer version or the streams API makes it more composable. Now, if you want to add an intermediate filter, map, or any operation, which makes it much easier. So with the small cost of learning functional paradigm, we get the benefit of more modular code and more composable code. Also, an important factor is like the code also happens to be declarative code, though functional programming is not the only way to have declarative code. You could also use sometimes like say an annotation based approach to make the code slightly more declarative, but you may not get the benefit of composing in annotation based APIs. And it's also important that you learn multiple paradigms, which can really change the way you think. Again, when people started with the object-oriented paradigm, procedural paradigm was quite popular, and I have seen like people would always fill a class with too many details, not having enough classes, not having enough modularity. The only reason why people would use classes is to make use of inheritance, which is also not right. So that paradigm inertia we saw when there was procedural was mainstream and people were migrating to object oriented paradigm, And similar inertia may be seen when you're moving from object oriented to functional. By moving, I mean not throw away object oriented and move to functional paradigm. You embrace the newer one. So and interestingly, it's always first time you have the maximum challenge, right? You will always think in the old paradigm way, and your brain resists to think in the newer paradigm. Once you cross that boundary, it takes a while. You put that effort and cross that, then of course your code is much better, your design is much better. And interestingly, learning the next paradigm becomes much more easier. It's the first it's the second programming language which is hard to learn, right? I'm assuming like there is a paradigm shift also, not just a syntax difference. Now, usually what, looking at this code, it would look like, I'm doing the filtering all the even numbers first, then I'm squaring all of them, then I'm just finding the first one. So I just need one number here. Why should I waste all my, time squaring and, filtering all the numbers from the list is the question typically comes. But under the hood, streams execution is interweaved, even though at your level it's all separate, but it's interweaved so that in effect it's the same as what the code you would write below. So what happens here is that what you see is not what you get. Just by looking at the API, you can't understand what is going on under the hood. So what's always, lazy evaluation is the benefit you get, but what's very important here is you understand one level below the abstraction you are dealing with. Of course, if you could understand more layers below that is good, but it's at least one level below you are operating with is something extremely helpful. And it might be extremely hard to go all the way till the hardware, because usually these days you may run the application in a container which runs on several layers of virtualization before reaching hardware. So I can totally understand how hard it could be. You don't have to do that. Just one level below the layer you're dealing with can always help. You never know when you need that. Let's see how sometimes, even though Java has evolved, certain bad practices or certain bad decisions, or certain decisions which were right in a particular context just spread everywhere. And Java Beans API is something I would specifically want to point out. In this case, it's code from the Bean introspector.java of JDK. You see that how it is still has a reference to java.awt, even though AWT has got nothing to do with I mean, in the sense it shouldn't have been truly coupled, right? Of course, Bean's specification was really useful for you have a GUI component which has to set and get several properties of a class. In that case, get something, set something, that convention was really useful. But what happened is the side effect of that was people created classes with every field having getters and setters, throwing away the principles of encapsulation, which resulted in a very, very bad code. So let me show you how typically, people who are highly influenced by, Bean specification write the code like this. So you would say you have create a new instance of pizza and you want to give that to a friend. You'll say like friend.getMouth.set food, all, the violation of Demeter, the law of Demeter, you might be aware of. So what's a better, so don't ask, right? That's the Demeter principle. So here you say friend.offer food, which this is a much better way of representing this, so that offer method has all the details of whether it should be fed to mouth or whatever, right? That's how that's the encapsulation what you need to understand here. One of the main, I mean, today we see a lot of object-oriented bashing, but at the same time, people of all good features of OO. I still think OO is relevant. It's pretty useful, though I'm not saying that OO is the only good thing in the world. Of course, you have good things in other paradigms as well, and depending on your context, you can take advantage of one or more, especially since languages are multi-paradigm today. You don't have to go to multiple languages to make use of or take advantage of multiple paradigms. So that was about encapsulation, and interestingly, over a period, we have learned that checked exceptions don't do something really great. Even runtime exceptions, with the runtime exceptions, you can achieve this. I don't have a good example, but I believe that's fairly evident. It's like initially when I started my professional career, we had version control systems that were using locking, right? So somebody would lock and keep, then you will have to, I mean, it's you feel great when somebody comes to you, hey, could you please unlock that file or release that file, right? But at the same time, when you have to work and some other developer has a lock on that, okay, then you have to go and beg him, okay, please release the lock. And that's not a good experience. But and especially with the open source spreading, we realize that you don't need that kind of control, right? People can behave well, and with the coordination, you really don't end up breaking things, right? That's something we have learned all the way. The same way here, if you force people to write exception handling code, they'll just way back I had code, it was a library which people asked me to use in the enterprise. Hey, this is a new library we created which can parse XML and all. Interestingly, when I opened the source code and saw that they had empty catch blocks. Even so, if it fails to parse a XML file, I wouldn't even know that it failed, which is really dangerous. So that's not the way to go about it. We have learned that. And an interesting part is like Java, today is a platform, not just a language. Even though when Java was started, it was a single language, multiple platforms, multiple OSs. But over a period of time, it's like multi-language and multiple platforms. So today, when I say Java, I really refer to platform. So I think I like a decade ago, I gave a presentation that Java beyond Java, to convey that Java is really a platform, not just a language. That was like a decade ago. And it's not just me, James Gosling, who has been attributed as father of Java, also acknowledges the fact, that, he also says that you may be surprised to hear this from me, but at the core of the Java ecosystem is the JVM. And you could see multiple languages started with, Scala, Groovy, and, Kotlin, and there are many more languages which are targeting. And we have here, TOB index. I wouldn't say that TOB index is the place to look for popular language, but it's one of the place which ranks use of languages across repository and all. You could go to their website and read more about how they do it. But then you would see Java is at number 2. There Groovy, which is another JVM language, which is at number 11. And there are other languages like Scala and Kotlin are also quite used on JVM these days. So with that, let me move to the multi-language aspect. So if you're using Java platform and you're developing application, I think going for other languages is a good option you have. Even if you're not using them in your production application, it's always good to learn at least one of them. Let me show one of the examples here. So in this case, I want to generate two string, right? So usually what you will do is you will go and use your IDE and say generate two string method. It will generate two string method. It's fine. Then later on, what I will do is I'll go to the class. Hey, I have first name and last name, 2 fields here, and I may need, okay, let me add a date of birth and a lot many fields. What happens to your toString? It is still relying upon only the 2 old fields, right? It doesn't get updated automatically. So one thing that what I realize is that those practices which think that code is written once are all not good for software development. The good principles of software development are the ones those realize that code evolves continuously, right? So in this case, toString is generated by compiler by putting this at toString is the transformation of Groovy, so that every time I add a field, obviously you'll have to compile, and compiler will generate that code. So every time your toString method is consistent. You would see how the corresponding, the equivalent of Java code, which there is that at generated, which shows that this is synthetic method. Similarly, you could put say immutable. In that case, I can't set anything, or say I say me dot first name actually calls the setter, not just the field being public. And similarly, you need to generate the getter here, which is also generated by the Groovy compiler automatically. All these are some of the advantages, of course, which can come to Java also. The equivalent in Kotlin is this. It's typical data classes. In Scala, you would say case classes, which are also immutable, which will generate the features are GA. You could always learn them. And especially with the Java becoming to in the 6 months release train, uh, I would highly recommend moving from one LTS version to another LTS version for most of the production application, unless say you have a small production application, unless say you have a smaller microservices kind of thing where you can always experiment and move on quickly. But it's a good thing that you can always try out the new features, and you're ready, you are well aware of the features, and when finally you have it in an LTS version, you could make use of that. And if you want to use it in Java today, of course, you have Lombok, which is doing something similar. You could see that all these classes are generated. So yeah, you can always learn multiple languages. Of course, I wouldn't confine it to JVM languages. You could learn any of those languages, even if you are not going to use those languages for your day-to-day work. The way you think will tremendously change. And I'm sure if you learn say for example Haskell, the way you write your Java code is going to change a lot. The way you think improves tremendously. And let me move to the final section here. That is where we talk about a little bit of feature abuse, right? Just because of there is a newer feature, you don't have to use it. So in my list of most abused features, the number one goes to inheritance. Right? When you have a hammer, everything looks like a nail. So inheritance, okay, I have a class which has some functionality there. Why not say, let me reuse those functionality here? Okay, my class extends that class. That's not the real reason for using inheritance, right? Inheritance is for Liskov substitution principle, right? Client has an interface. Okay, this is the contract now, and whichever class implements that, or I mean the variants of that, you can always have inheritance from a class to multiple other child classes, not really to make use of reuse or something from the base class, which may be that I understand that there is a genuine problem, maybe deficiency in the language, but otherwise you should not be using. It's like you might have seen like 3D extending 2D, a lot of wrong examples out there, though. And we know that Favour object composition over class inheritance. We have heard it from Gang of Four and from effective Java, all these places. But often it is the most abused feature. The second in my list is default methods. Interestingly, the the biggest user base, or the one who really needed the default methods, are the Java standard library developers. If you're maintaining a library, then there is a small chance that default method may be helpful. And if you're an application developer, then I don't see any reason why you should be using default methods. So previously we had this separation of concern, right? Interface is like a contract, and now implementation has the all the implementation details there. So interface was purely a contract, and the reason why this gets mixed up is in the modern frameworks we follow the philosophy of convention over configuration, right? So by default, this is the implementation. This is how error gets handled. This is how say cache did not have the data, how you intercept that and it gets handled. All these are kind of default supplied by the framework, but those need not be implemented as default methods. So the real disadvantage is that when you as a developer have to implement that method, okay, now compiler will not complain you have not overridden default method. So whatever is the implementation is not a conscious decision by you. If you had to implement, okay, now how error should be handled, or error should be handled, or should I ignore it, boolean true or false, as a developer you would make a conscious decision. Now you're not doing that. And I was going through the source code of some famous open source projects, and I saw a lot of, even which is developed by some of the great developers in the world for sure. However, it things got mixed up there, which is not good in my opinion. So it's very important that these features we have to use. The question why this feature is there, why you are using it, or if you have already experienced the pain, you will readily go and embrace that solution. I'm sure that, right? And strive for simplicity. Most of the time, we think familiarity is the only way to deal with simplicity, right? Because you are familiar, you are able to handle that. If you're not familiar, you're not able to handle that. That's the typical approach. But by using the principles, whatever we have seen before, we could make sure that we could achieve simplicity, not just with the familiarity. Of course, you can always break that familiarity ring, learn more things, right? More modular code, encapsulation, make it work, make it better. All are applicable here. And with that, I would say that the true nature of code is evolution, right? Anytime you may look at the code, you just see the snapshot. You don't understand how it evolved. So if you really want to be a good developer, and the best way to learn is pair with other developers, or you make use of mock programming, and you see code evolving from one state to another, learning that, evolving that, the experience of, or maybe you are having a pet project for several years, and you evolve the code all this time. The experience you get from there is truly helpful, which is quite different from looking at the finished code. So I would highly recommend you to embrace pairing with others, or mobbing with others, do like code retreat. All these kind of things can really help you to become a good developer with a lot of deliberate practice. With that, I would like to thank the organizers for organizing this amazing conference. I'm sure it has helped so many of you, especially being in this online mode. And I hope, I managed to give my 2 cents to the community. And if that, you learned something from that and save some time for you, that I'll be really happy about that. With that, any questions? Well, yeah, the question on do you intend to write a book? I think, yeah, that's a good idea. I believe I would surely consider that. Java developers, both seasoned and the newcomers, will surely benefit from learning how to keep up with the pace. Well, thanks for that.
Naresha, you have a question for Mani in the chat.
Mm-hmm. Okay, yes.
Do you want me to read it? What do you recommend they continue doing to keep up with the pace?
First thing I would like to say, yeah, deliberate practice is something, and definitely, participating community in whatever they can. Read open source, write about it. As if you have something value, contribute, back to that. I think, yeah. So any intention to create value will always be resulting in something good. Pace is mainly, I think, experience, which is highly driven by deliberate practice. In what context you get to work, I believe you may not have full control on that, but as long as you keep an open mind and understand that things will keep evolving, and keep asking that question, keep observing, increasing the sensitivity to pain, can always lead multiple. Okay, these are all the 10 things what I can do, but what would be the priority? Pick that. Meanwhile, deliberate practices can help you to get better test-driven development, refactoring, any of those. And language features will keep coming in to make things better. Multiple paradigms, multiple languages, those will always open up more solution options, I would say. Yeah, so I believe it's a mix of all these.
Thanks, Naresha, for being with us for the Java Today's virtual edition. Guys, this is the last session for this year's conference. So thank you all of you for being with us, and maybe see you next year. Happy holidays to all of you, and bye.
Thanks, everyone. Merry Christmas and Happy New Year.